When you sit quietly, maybe at your desk or on a chair, and you look around the room, you notice something that feels entirely normal, entirely obvious. The table under your hand is solid. The floor beneath your feet holds your weight without question. The walls and the ceiling stay where they are. It seems simple, it seems reliable. And yet, if you stop for a moment, if you pause and think carefully, a strange and unsettling question arises. Why doesn't all this collapse? Why doesn't the matter around you crumble into nothing? Why do atoms, these tiny, almost unimaginably small building blocks of reality, exist in the way that they do? Why is there a gap between one particle and another, instead of everything collapsing into a singularity of chaos? It is almost a disturbing question, because the answer is not what your textbooks might have led you to believe. Most textbooks, when they introduce atoms, give you a simple, neat picture. There is a dense nucleus made of protons and neutrons, and there are electrons orbiting this nucleus like planets around the sun. And we nod, because it looks reasonable. It is tidy, it is simple. But look closer. If electrons are attracted to the nucleus as the electric force dictates, then they should spiral inward. They should collide with the nucleus and the atom should vanish immediately. End of chemistry, end of matter, end of everything. And yet here we are. That impossibility is exactly why atoms exist. That impossibility is the foundation of all matter. To grasp this, let's step away from atoms for a moment and think about something more familiar. Imagine a crowded room. Some people are trying to get closer together, pushing inward. Others want personal space and pull back. If everyone only pushes inward, the room collapses into chaos. If everyone only moves outward, nothing holds together. Stability arises only when opposing tendencies reach a balance. Atoms operate similarly. There is an irresistible pull inward. The opposite charges cannot help themselves, but there is also a counteracting resistance. This resistance is not a force you can touch. It is a rule built into the universe itself. Not glue, not scaffolding, not some external support. It is a law that forbids certain configurations. This law is absolute. Electrons cannot be confined perfectly to the nucleus. Why? Because the universe itself forbids it. There is a principle, subtle and fundamental. You cannot know both the position and the momentum of a particle perfectly. Not because of faulty instruments, but because the universe simply will not allow it. The tighter you try to confine an electron, the more energy it possesses. Push it too close, and the energy cost becomes enormous. The electron spreads out, becoming a cloud of probabilities neither here nor there, yet settled in a delicate balance. That compromise is what allows atoms to exist. That compromise is why you exist. Think about the implications. Nothing holds matter up externally. There is no scaffolding, no invisible glue, no external magic. Matter exists because collapse is forbidden. The table you touch, the chair you sit on, the person across from you, they all exist because their atoms are prevented from collapsing by the fundamental laws of nature. The solidity you perceive is not solidity in the classical sense. It is resistance. Resistance enforced by the universe itself. Your hand does not pass through a table because the universe refuses to allow atoms to occupy the same space. Most people never think about this. They are taught labels, diagrams, and names of particles. But these explanations skim past the profound truth. Reality does not obey human intuition. It is not built for comfort or comprehension. At the smallest scales, the universe behaves in ways that can seem absurd, even impossible, if judged by common sense. And yet, those rules allow everything, every molecule, every star, every living being, to exist. Atomic stability is a profound testimony to the elegance and subtlety embedded in the universe. To make this more tangible, consider everyday analogies. Imagine a spring. You can compress it, and it resists. Push too hard, and it pushes back stronger. Atoms behave like that spring, except the spring is embedded in the laws of reality. Try to compress the electron cloud too tightly, and the spring pushes back with energy. Or imagine a crowd at a concert. If everyone moves inward to the stage, the crowd jams. If everyone tries to retreat at the same time, the crowd dissolves. Stability arises only because there are limits to how close or far the participants can be. Nature enforces those limits on electrons and nuclei, and in doing so allows matter to exist. Even the way electrons occupy space is fascinating. They do not orbit like planets in perfect circles. They exist as probability clouds, fuzzy and spread out. The more you try to confine them, the more energy they gain, and the more they resist. Confinement itself costs energy. Resistance is built into the very fabric of reality. That's why atoms don't collapse. That's why the chair you sit on, the desk you work at, the stars above, the very air you breathe, all maintain structure. And the more you think about it, the stranger it becomes. Nothing is physically pushing the electrons away from the nucleus. Nothing is holding the table up from some invisible force. All that stability emerges from the laws themselves, quietly enforcing order, refusing collapse, creating space where particles can exist without destroying each other. It is the universe maintaining balance in the most subtle, elegant way imaginable. You start to realize that solid objects are not solid at all. What you perceive as solidity is actually the resistance arising from quantum laws, from probabilities, from the delicate balance of attraction and repulsion. Every surface you touch, every object you see, exists because of this delicate equilibrium. And when you understand that, you cannot look at matter in the same way again. Even thinking about this is unsettling. Most human intuition fails at this scale. The rules of reality are not built for comfort or common sense. And yet, those same rules allow stars to shine, planets to form, life to arise, consciousness to emerge. Atomic balance is mirrored at every scale of existence. Stability is never a triumph of a single force. It is compromise, equilibrium, a dance of opposing tendencies, and that is precisely what Feynman wanted us to appreciate, the hidden complexity behind what seems ordinary and simple. As we continue, notice how the universe does not simply permit life, matter, or consciousness by chance. Every particle, every interaction, every electron cloud exists in a delicate harmony. Change a single law slightly, and electrons would collapse into nuclei. No molecules, no water, no DNA, no life. And yet, improbably, here we are, perched on the edge of possibility, existing only because the universe forbids collapse. The universe is strict, precise, and astonishingly clever. Now, let's dive deeper into what really keeps atoms from collapsing. We have already seen that electrons cannot simply fall into the nucleus, and that the solid objects around us exist because the universe enforces limits. But how does this actually work? Intuitively, without equations. How does the universe create a balance between attraction and resistance so elegant that it allows all matter to exist? Think of it this way. Attraction is always present. The positive charge of the nucleus pulls the negatively charged electrons relentlessly inward. If this were the whole story, collapse would be inevitable. But nature adds resistance in the form of something truly stray, NGE, and wonderful. The more you try to confine an electron, the more energy it demands. It is as if the universe itself whispers, "No, you cannot be squeezed any tighter." Try to confine it, and it resists more strongly, not because of a visible wall or a force you can touch, but because of a principle woven into reality itself. Imagine trying to fit a crowd of people into a tiny elevator. Push them closer and closer, and the pressure grows. Each person resists, moving slightly outward. You cannot confine them perfectly. The tighter you push, the stronger the pushback. Electrons act similarly, except that the pushback is energy. The tighter you try to confine an electron to the nucleus, the faster it must move, the more energy it possesses, and the stronger its resistance becomes. This is not abstract. It is the mechanism that allows matter to exist at all. Now, consider the nature of space inside an atom. Electrons do not travel in simple circles like planets around the sun. They exist as clouds of probability, fuzzy and spread out. The universe refuses to let them have both exact position and exact momentum. The more you know about where the electron is, the less you can know about how fast it is moving, and vice versa. Confinement itself carries an energetic cost. The electron's very existence is a compromise between attraction to the nucleus and the energy cost of confinement. This compromise is the key. Matter exists because particles are neither completely free nor completely trapped. They live in this delicate balance that the universe allows. and this balance repeats itself at every level. If we zoom out, the atoms form molecules. Molecules form solids and liquids. Solids and liquids form stars, planets, and life. The cosmic order emerges from the simple principle that collapse is forbidden, that confinement carries a cost, and that resistance is built into the fabric of reality. To make it more tangible, think about springs again. Compress a spring and it pushes back. But imagine a spring that gets stiffer the more you try to compress it, in such a way that it never allows full collapse. That is precisely what happens inside atoms. Electrons are confined by the nucleus, but nature ensures that the confinement energy rises as the electron is squeezed. This pushback is absolute. It is part of the structure of the universe, invisible, uncompromising, yet entirely elegant. Or imagine an enormous dance floor filled with dancers. The floor is crowded, and the dancers are constantly moving, adjusting their positions. Each dancer is attracted to the center of the floor, yet they cannot occupy the same space. They spread out, creating a dynamic balance, a cloud of probability where every position is possible, but constrained by the rules. That is exactly how electrons behave. The universe choreographs the dance, and the result is stability. Consider the idea of forbidden collapse further. The energy of confinement cannot be ignored. If electrons tried to fall into the nucleus, they would gain enormous kinetic energy, moving faster and faster, generating pressure that pushes them back out. Nature prevents total collapse, and in doing so, allows all structure to exist. Without this delicate balance, there would be no atoms. Without atoms, there would be no molecules, no chemistry, no water, no life. The very existence of reality hinges on this principle. Think about it philosophically for a moment. Stability is not the result of a single force prevailing. It is a compromise. It is equilibrium between attraction and resistance. It is balance enforced by rules so subtle that we only notice their effects indirectly. The solidity of a table, the weight of a chair, the persistence of matter itself. Human intuition fails here. The laws do not obey common sense. They obey logic beyond immediate perception. Logic so elegant that it creates stars, planets, and life itself. We can also consider multiple metaphors to make this fully sink in. Imagine magnets. You bring opposite poles together and they attract. But push them too close, and something resists. It is not arbitrary. It is the field itself that prevents overlap. Or imagine traffic on a highway. Cars cannot occupy the same space. Even if each driver wants to move forward, rules prevent collisions. That is a human-scale metaphor for quantum exclusion and the balance of forces in atoms. The principle is universal. Matter maintains order because collapse is forbidden. Even the structure of solids and liquids emerges from this. The reason chairs and floors feel solid is not because the electrons are glued together in some classical sense. The electrons repel each other at short distances. The Pauli exclusion principle, the quantum nature of particles, the cost of confinement, all of these combine to create a stable lattice. Everything we touch, everything we see, is a consequence of these invisible rules working perfectly in harmony. At this stage, it becomes clear why textbooks rarely explain this properly. They present a diagram, they name the nucleus, they draw electrons in orbits, and that is the end. But the truth is far more fascinating, far more subtle. Reality is not simple. It is layered, counterintuitive, and beautiful. Atoms exist not because they are told to, not because they are commanded, but because the laws forbid collapse and enforce compromise. That is what makes matter, and ultimately life, possible. And as we reflect, we see the connection between atomic balance and the cosmos. Stars shine because gravity pulls inward and pressure pushes outward. Life exists because countless opposing forces maintain equilibrium. Ideas and thoughts survive because tension exists between curiosity and skepticism. Stability is never the victory of a single tendency. It is always the result of compromise. Atoms teach this lesson in the most literal, uncompromising way imaginable. As we reach this point, let's step back and consider what all of this reveals about reality itself. We have explored the attraction of electrons to nuclei, the resistance enforced by the universe, and the delicate compromises that allow atoms to exist. But the story does not end there. Understanding atomic stability changes the way you perceive everything around you. It challenges your intuition, humbles your assumptions, and expands your sense of wonder. Think about the stars. A star is essentially a massive collection of atoms held together by gravity, yet balanced by pressure. Nuclear reactions light the star, and energy radiates outward. Without the same principles of balance that govern electrons and atoms, there would be no stars, no fusion, no heat, no light. The stability of matter at the smallest scale is mirrored in the cosmos. The same delicate equilibrium that prevents electrons from collapsing into nuclei is echoed in the very forces that allow planets to form, oceans to exist, and life to emerge. Consider life itself. You are made of atoms, held together not by magic, but by the invisible, uncompromising laws of quantum mechanics. Your body persists because electrons resist collapse, because the universe enforces balance, because molecules can exist without dissolving into chaos. Every thought you have, every step you take, every heartbeat, all of it rests upon the same delicate principles. Change them slightly, and existence as we know it would be impossible. Atomic balance is not a small detail, it is the foundation of reality itself. Philosophically, this is astonishing. Human intuition fails at the atomic scale. We imagine solids as solid, matter as simple, reality as obvious. And yet, when we probe deeply, we discover that what we perceive as ordinary is in fact the outcome of extraordinary rules, subtle balances, and forbidden collapses. We are perched upon a structure that is at once fragile and resilient. Our existence is contingent upon principles that cannot be grasped by common sense alone. It is a humbling realization, one that fills the mind with awe. The more you think about it, the more profound it becomes. Atoms exist because the universe forbids their destruction, and that same principle resonates throughout nature. Stars, planets, life, and consciousness are all expressions of this balance. Stability is never the triumph of a single force, but the product of equilibrium. The universe is exacting, precise, and astonishingly clever. The laws that prevent electrons from collapsing into nuclei also permit everything we call reality to exist. That is a truth both beautiful and unsettling. Even the tiniest particles participate in this cosmic dance. Electrons, protons, neutrons, all constrained by principles beyond intuition. They obey rules that ensure that collapse cannot occur, that balance emerges, that order prevails over chaos. And yet, these rules also leave room for freedom, for unpredictability, for creativity. The universe is not rigid, it is disciplined, subtle, and elegant. And in understanding this, we gain perspective, not just on atoms, but on ourselves, on life, on the cosmos. Pause for a moment and reflect on the implications. The solidity you take for granted, the reliability of matter, the persistence of life, all rest upon these principles. And yet, they are invisible, intangible, and utterly subtle. You cannot touch them directly. You cannot see them with your eyes. You can only infer their existence through the consequences. The table holds your hand, the floor supports your weight, your body maintains structure. All of this is a triumph of balance, enforced by the laws of nature. Now, think about the uncertainty, the impossibility, the awe of it all. Atoms exist not because they recommended to exist, but because collapse is forbidden. Life exists not because it is guaranteed, but because delicate balances allow it. Consciousness arises not because it was intended, but because rules at the smallest scale combine in such a way that complex systems can emerge. Reality is fragile, improbable, and astonishingly elegant. And that is the lesson Feynman wanted us to see, not only the mechanics of the universe, but its poetry, its mystery, and its beauty. And so we come to the edge of understanding. Even after all this exploration, we do not have complete answers. Why are the laws of nature exactly this way? Why is collapse forbidden? Why does the universe permit the improbable equilibrium that allows atoms, life, and consciousness to exist? These questions remain unanswered, echoing silently through the mind. Feynman often emphasized that understanding the questions is as valuable as knowing the answers. The beauty of the universe lies not in certainty, but in the curiosity it inspires. As you sit here, perhaps looking around your room, consider that everything you perceive, every object, every person, every living creature, is the outcome of invisible rules, forbidden collapses, and delicate balances. Atoms exist because the universe will not allow them to fall apart. Matter persists because the universe enforces compromise. And in contemplating this, we realize that reality itself is a symphony of order and balance, subtle and profound, more beautiful than we can fully comprehend. There is a final thought I leave with you. The next time you touch a table, or feel a chair, or hold a book in your hand, remember that it exists because collapse is forbidden. It exists because electrons resist the pull of the nucleus, because quantum principles enforce limits, because balance prevails over chaos. You exist because the universe allows it. And in that recognition, the ordinary becomes extraordinary. The familiar becomes mysterious. And the mystery itself is a gift, a reason to remain curious, a reason to explore, a reason to marvel. Perhaps the most profound lesson is this: understanding atoms changes the way you see everything. Solids are not solid. Space is not empty. Matter is not matter in the classical sense. Reality is a dance of balance, compromise, and subtle laws. And in this dance we exist, observe, and think. And that is why atoms exist. Not by accident, not by command, but by the delicate, invisible, astonishing rules of the universe. And as we leave this thought lingering, remember that the universe holds its secrets close. We glimpse them, we marvel at them, we reflect on them, but the ultimate truth remains elusive. And perhaps that is the point. Perhaps the beauty of atoms, of matter, of life, of consciousness, lies in their mystery. It is a mystery that invites curiosity, contemplation, and wonder. And in that invitation we are reminded that learning is not about certainty, but about embracing the unknown with courage, honesty, and curiosity. The universe is not merely a collection of particles. It is a story, a delicate equilibrium, a mystery that shapes everything. And in every moment you perceive, every sensation you feel, every thought you think, you are touching the edges of that story. You are witnessing the consequences of forbidden collapse, the harmony of balance, and the poetry of existence itself.